Hey guys, welcome back. We're going to do 10-3, 10-4, and 10-5. Let's take a look. 10-3 is chords. All right, so oftentimes we'd see a lot of the chords are the same length, or if they make a 90, they make right triangles, and we can use Pythagorean theorem. Cool? All right, so let's dive in. Question number 15 says, FH is what we want to know, okay? And round to the nearest tenth if we need it. It says the radius is 7. Okay, so this would be 7, that would be 7, this would be 7, this would be 7, right? So that means that has to be 2, because if that is 5, makes sense? And that means this is probably going to be 2. We could use triangle theorems to prove it, but it looks like it's HL. So because of HL, this triangle has a hypotenuse that matches, hypotenuses match, a side that matches, a side that matches, right? So that's HL. The rest of this length, this would have to be 5 because of CPCTC, which means that has to be 2. Okay, CD. Well, let's see. We have a triangle. This is 5. That's 7. We can solve for that, right? So x squared plus 5 squared equals 7 squared. What do we get here? So x is equal to the square root of 24. What do we get? It said round to the nearest tenth, so 4.9. And that makes sense. If this is 5, this looks like a number a little smaller than 5. So we've solved for not CD, though, CF. So CD is equal to CF plus FD, and both of them are 4.9 times 4 times. So I'm going to double that, and I get 9.8. So I doubled that. All right, what's the angle BTA? What's my angle BTA? What do we got going on here? I got to clear out some of this stuff to be able to see. I can't see. There's too much going on. Okay, so this is 44, so that means its central angle is 44. And we proved all these triangles are equal. So this would be 44, this would be 44, that would be 44. Okay, so BTA, all right, now that I cleared that out, this would be the sum of that. Got it? All right, looking for a relationship. Circle T and S intersect at point A and B. What is the relationship between A, B, and TS? So we got two circles that intersect, all right, at A and at B. So it looks like a Venn diagram. What's my relationship between A, B, and TS? Ooh, this is kind of interesting. Wouldn't that have to be perpendicular? You can try drawing it any other way, but it looks like it's going to have to be perpendicular. That was a neat little question. All right, question 19 says, a contractor cuts off part of the circular countertop so that it fits against a wall. What should be the length of X? All right, round to the nearest 10. So we know that this is equal to the radius, and if all the way across is that's the diameter, right? So the radius is 60. So this is 60, this is 60, this would be 60, so 100 minus 60 would be 40. This part is 40, okay? And that's a 90-degree angle. So we're solving for X all the way across, but we're gonna have to solve for Y first and then double it, okay? So I have a triangle here. I'm going to say 40 squared plus y squared equals 60 squared. So that would be 1,600, 3,600, Oh, sorry, my Zoom started to not work. And it says round to the nearest 10th. So I want the square root of that. Square root of 2,000 is 44.7. And that number makes sense. I knew it was a number smaller than 60, but bigger than that, right? 44.7, but I want to double it. And this other side. So we'll double it. And we get 89.4. And I think that number makes sense here, 89.4. Cool. All right, 10-4. After reviewing this and noticing the tip of the cone is half the snow, let's play around with a few of these questions, right? So EF is the tip of this is this cone, right? And interestingly enough, this is the same snow. So these angles have to be equal. If this was 30, this has to be 15, and this also would have to be 15. It might not be 15, but it makes sense that I should set these equal to solve. Okay, so set these angles equal to each other to solve. I'm going to do that over here, right? 5x plus 14. I think it'd make more sense to subtract 5x. And then add 6. And then divide 4. So what is x? It's 5. Okay, cool. So if x is 5, this would be 25 plus 14, or 39. And again, if this is 5, that'd be 45 take away 6, which is 39. We know that this angle is 39. And this angle is 39. So what would EF be? Twice that. 39 doubled. 78. Okay. Ooh, that was fun. All right, here it says this is 163. Okay. Here, let's make sure we can see what's happening here. The tip of the cone is 51, which means this snow here is 102, because that's half. So we almost have all the way around. Right, this last little bit we can solve. Right, so I have 360. Take away 163, take away 102. What's left over? I get 95. Okay, so if that's 95, then this angle, right, it would be half that. So half of 95 would be 47.5. Okay, what do they want? M and P, that's what they want. So I get 47.5. Right? Cool. Now I gave you a shortcut on 22. I said, these have to be angles opposite each other, have to add up to 180. Because if we think about this arc plus this arc has to add up to 360. So these two angles have to add up to 360. Okay, so 6x and 9x have to add up to, 180. Half of that. All right, so that would give me 15. So what's 180 divided by 15? I get 12. Okay, so what is WZY? WZY. Ugh, they're so mean to me. I got to solve for all these angles. Okay, so 6 times 12 is 72. So I'm going to redraw this. This one is 72, 6 times 12. 9 times 12 is 108. 8 times 12 plus 5, right? Is 101. Okay, so this is 101. So what do I have left? So I have 360, take away all these numbers. Take away 101, take away 108, take away with 72. But again, remember, these two have to add up to 180. So that would make this one 79. So my answer is 79. Whew. Okay, what about this one? We see a triangle. We know that's 71, right? And then we know this one would be what's left over from 180. So 180 take away 71, take away 59. We get 50. Okay, what is, they're asking, Q, P, R. Interesting. Well, the tip of the cone, 50, that means that this has to have 100 degrees of snow because the tip of the cone is half the snow, 50. So here, this tip of the cone would also have to be 50 because they share the same snow. So my answer is 50. Whew. If a rectangle is inscribed in a circle, stuck inside, what must be true about its diagonals? They must be equal to the diagonals are diameters. That would have to go through the center. Cool, because we know diameters are equal. Last one. This one's probably my favorite. Okay, so we drew this picture. A times B has to equal C times D. So that's how we want to set this up. Let's call that X, right? QR we're solving for, so let's call that X. So I set this up, 10 times X, right, is equal to 5 times 12. So we get our answer 6. Okay, and the number makes 6. 6 times 10 is 60. 5 times 12 is 60. All right, what about this angle? So they laid 2 of these on top, so now they're asking for an angle, so I can think of it from a different perspective, right? I know that the big arc plus the little arc has to equal to this angle or that angle, right? It's the average. So 81 plus 43, cut that in half, is the interior angle. And I get 62. Now let's just make sure that's what they wanted. So they wanted the angle NRP. Yes, so we solved for that 62 degrees. Beautiful. Okay, 3 more questions and we're done. It says solve for WZ. Okay, I'll call that X. And we know this is 8, and we know this is 8 plus 10, or 18. Okay, so those are the pieces we need. So to solve for WZ, we say the outside times the whole thing has to equal the outside times the whole thing. So the part on the outside is 8. The whole thing is 8 plus 10. The part on the outside here is X, and the whole thing is actually also X. So we get 8 times 18 is X squared. Ooh, that's pretty handy. So the reason why that's handy is it's the number 12. So this has to be 12. Does that make sense? Yes. 12 times 12 is equal to 8 times 18 because they both equal 144. So that solves that little mystery. All right, what is the measure of arc X Z? All right, I might have to erase some of this to really be able to see what the heck it is I'm doing here. So what is the measure of? So I have this, right? It created a big arc, right? And it created a little arc. And I have to take, to solve for that exterior angle, I have to take the big arc, 187, minus the little arc, which I don't think they gave me. So I'm going to call that y. I don't know what it is. And then I divide by 2, and then I get this angle 74, okay? So I just have to do a little bit of algebra. Okay, if I'm going to do algebra, I'm going to multiply both sides by 2. So we get 8, 148. 187 minus y, okay? So if I add y to both sides, all right, and subtract, I get 39. Okay, and if I plug that back in, that should work. So they want to know the measure of XC, and we got 39 because 187 minus 39 cut in half should equal the number 74. Okay, last question. Construct an argument. A student said that if angle A is formed by two secants intersecting outside, so that's this formula here, outside, we're going to subtract, then angle A has to be less than 90. Do we agree? Okay, so let's try to draw this. If I try to draw an angle out here that's 90, I can't, oh, that's interesting. I can't get through there. So it does feel like this might be right. What's the biggest angle I can get? Yeah, it looks like the biggest angle I can possibly get practically here is going to be less than 90. So yes, our exterior angle must be less than 90. Cool. Thanks for joining us, guys.